Hello Year 12 and welcome to the 8th and final video for this 6th topic on the sine and cosine rules. We're talking about solving problems. A little reminder, 2 sides, 2 angles, probably the sine rule. 3 sides, 1 angle, probably the cosine rule. Unless you're finding the area. Right. Now, these questions here that you'll see in example 11 are really very common where you have 2 triangles. One of them is a right angle triangle. These are quite common. There's usually more than one way to get to the bottom of them, but I will show you one. First of all, it says, show that A equals this. Now, you can't substitute in and test that it works or something like that. Right? Don't work with this. You can't sort of substitute this in at any stage. Right? We're just going to find A, and we need to express it in this form here. To show that that's true. The reason that these questions are asked very frequently in HSC is because you're going to need this result for the next question, and it's such a shame if you can't calculate the first result, then you can't answer the second question at all. So, by asking this way, show that this is the answer, then even if you weren't able to show that, you can still use it for the second part. Let's have a look here at how we're going to solve part A. This is the side I'm trying to find. Now, I have a triangle here, a right-angled triangle. I've got an angle. I don't know that side. I don't know that side. Frankly, if I don't have any of the sides of a triangle, I'm not going anywhere with it. All I can find is angles. Right? If I don't have any sides, I can't find any sides. So that's not going to be much help to us. We're going to have to rely on this non-right-angled triangle here, this obtuse triangle. Now, I do have this side here. I don't have its opposite angle. I don't have all 3 sides. It's not a cosine rule question. I've got what appears to be one angle, and 2 sides. Right, 1 angle and 2 sides. I can't get this side very easily, so what I'm going to need is another angle. Now 36 and this angle in here, they're going to form a straight angle. They are supplementary angles. So this angle here could be found by taking 36 away from 180, which gives us 144 degrees. Right. Feel free to write this on your diagram. That's perfectly fine. So I've got that angle there. That's good. Now I've got 2 angles, 2 sides. I don't have the opposite pairs yet. The 11 and the A, that's good. The 80, and this one here. So if I could find this angle here, I'll be in a much better position. Together my 3 angles add up to 180 degrees. 144 plus 11 is 155, which makes this angle up here 25 degrees. It should be okay in an exam, as long as you write that on your diagram. That will sort of demonstrate that you've calculated that. Right? But if I say 180 minus 36 equals 144, and 180 minus 11 minus 144 equals 25. Rightio. There's much of things there. Now I have my x here, 25 degrees in the 80, and the 11 and the A, right, my pair of opposite sides and angles. So now I use the sine rule. Right, I'm just going to do this over here, part A. I'm going to say that A over sine 11 equals 80 over sine 25 degrees. Right, now I can't start here. I do have to put those angles in there to show where those numbers came from. Therefore, A equals 80 sine 11 over sine 25 as required. There we go, done. Now for part B, evaluate, right, hence use the previous result. Evaluate the height h, the tower correct to 2 significant figures. Well, how are we going to do this? I can punch this into my calculator, 80 sine 11 on sine 25, and find out the length of A. Once I've got A, I've got a right angle triangle with 2 sides and 1 angle. Right. I'll know what this side is. I want to find the other one, and that's going to be all the way back to our first exercise here using right-angle trigonometry to solve a problem. So, first of all, I'm going to evaluate A. A equals, where's my calculator? Here it is. Clear that away. And I've got 80 sine, oh, in fact, let's type it in like this. We'll go 80 sine 11 over sine 25 equal, doesn't like that. 80 sine 11, put a bracket on there, over the sine of 25 and my close bracket. See how that goes. There we go. Is about 36.119 metres. Thereabouts. You know, to the nearest millimetre. There we go. Now, looking at this right angle triangle, we'll put the right angle in there, I have the hypotenuse, and I want to find the opposite side. So opposite hypotenuse is sine. And I'm going to say that the sine of 36 degrees equals the opposite on hypotenuse is h over 36.119. Therefore, h is 36.119 sine 36 degrees equals, now back to my calculator, don't use the rounded off answer, right, just use what was previously there on the screen, and we'll multiply that by the sine of 36 degrees, and we get 21, what was it, two significant figures, 21 metres. Two significant figures. Probably shouldn't have said metres there, you know, because it's h metres in the question. H equals 21. Like that. And they can be, right, there's a few variations on them, and they get a little bit, you know, a little bit interesting at times. But remember the tools that you've got, your right angle trigonometry, even sometimes Pythagoras, right, for right angle triangles. Your right angle trigonometry, two sides, two angles, sine rule, three sides, one angle, cosine rule, and the SOHCAHTOA. Find what you can, use your diagram, write things on there as you go along. Angle sum of a triangle, a straight angle equaling 180 degrees, all of this knowledge that you've accumulated over the years, each of those might be helpful in solving these problems, right? But they require a little bit of puzzling along. If the answer doesn't come to you immediately, don't worry about it. Work out what you can and see if that gets you closer towards a simpler problem. Rightio, that's it for our last video, sine and cosine rule. Hope you enjoy. If you've got some questions, please jot them down, ask me in class. See you then.